So when we're solving logarithmic equations, there's two basic types. The first one, like question A, is the simplest type of all. Question A, let's copy the question down again. We have a situation where we have a log equals another log. Nothing else. If we look at B, we have that 1 plus log of x plus 1. We don't have anything such as that 1 here. When we get a situation where it's log equals log, this is the easiest of all. We can just cancel the logs out and be left with the function of each log equaling each other, so 2x minus 1 equals 11. Then this turns into a basic type of solving equation. Add 1 to both sides, so 2x equals 12. And then divide by 2, so we have x equals 6. Again, this method of canceling logs only works when we have one log equals another log and nothing else there. So moving on, I'm going to do question C next because B is actually an expansion of question C in a way. With question C, log base 2 of x plus 3 squared equals 4. There's no way that we can get this to a point like what we had in question A where we had log equals log, since we only have one log in the equation. In that case, now we have basically just a logarithmic function. We can convert this up into exponential form. So 2 to the power of 4 equals x plus 3 squared. So when you have just one single log in an equation, convert it up to exponential, and then we can deal with this a little more easily. So we have 2 to the power of 4, we can work that out. That's 16 equals x plus 3 squared. And now to deal with this, we need to take a look back at pre-calculus 20 when we were solving quadratics because we have x plus 3 squared. We want to get rid of that exponent of 2. So if we square root both sides, that will cancel off the exponent of 2. But don't forget, when you put a square root into an equation, you need to have plus or minus with it. So then it works out, we have plus or minus, the square root of 16 is 4, and that's going to equal x plus 3. And at this point, we can split this into two separate equations. One where 4 equals x plus 3, the other one where negative 4 equals x plus 3. And then solve each one of those individually. So on the left, we'll subtract 3 from both sides, and we'll get that x equals 1. And on the right, again, we'll have to subtract 3 from both sides, but we'll get that x equals negative 7. Moving back to question B, we have log of 8x plus 4 equals 1 plus log of x plus 1. And the first thing you might notice is that neither of those logs have bases written with them. They do in fact have a base. It's base 10. That's assumed anytime we don't have a base that's written with the log. Second thing, this question looks a little bit like question A in the fact that we have logs on both sides of the equation, but we also have that 1 plus on the right side, which makes it impossible to just cancel the logs. So we need to in fact turn this into an equation that resembles C. So to do that, I'm going to take the log of x plus 1, that's on the right side, I'm going to move it to the left side. So I need to subtract it, but this is where things get a little bit tricky. Sometimes we'll see, oh, I can just subtract log. No, you can't. Log needs a function with it. You can't just subtract the x plus 1. You need to subtract log of x plus 1 on both sides to move that whole log function over. The second tricky piece comes into what the next step actually looks like. We can't combine those logs. There's no like terms to combine. They are logs of different functions. One of them is 8x plus 4, one of them is x plus 1. So we can do nothing else other than just write them out as is. So log of 8x plus 4 minus log of x plus 1, and that equals 1. However, doing this, now we have both of our logs on one side, they're subtracted, so we can go back and use the laws of logs to actually combine those two logs into one. We have two logs that are subtracted. When we combine them into a single log, it'll be one log of those functions divided. So log of 8x plus 4 over x plus 1 equals 1. And now this question actually quite closely resembles question C. So at this point we can take it and turn it into an exponential. Remembering here we have a log of base 10. So when we convert it, we will get 10 to the power of 1 equals 8x plus 4 over x plus 1. We've got a fraction there. We should probably think of a way to get rid of it. Easiest way to do that is cross multiplying, but we need a 1 underneath the left side. So let's move up here. On the first set, we'll have 1 times 8x plus 4. So that is 8x plus 4, which is going to equal 10 to the power of 1, which is 10, times x plus 1, so that's going to equal 10x plus 10. Now we're at a point we just need to figure out what x is, so if I subtract 8x from both sides, next step we'll have 4 equals 2x plus 10. Subtract 10 from both sides, we get negative 6 equals 2x. And divide by 2, we get that x equals negative 3.